Energy. It's everywhere. All around us. Used to power our everyday lives, from cars, lights, heating, and, yes, the very computer used to animate this production. Welcome to the Energy Mall. Glorious, isn't it? Home to all sorts of different energy stores. 10, to be exact. Now, these aren't your ordinary stores. No fine jewelry and fancy gadgets here. These little guys are not created, nor can they be destroyed. So no life insurance needed here, then. Now, let's meet the stores. First we have Magnetic. These two are practically drawn together. The relationship has its positives and its negatives, but after all, opposites do attract. When these like-minded poles, no, not like our European friends, are pushed together, energy is stored. Examples include fridge magnets, compasses, and maglev trains. Now doesn't that just draw you in? Now, let's pull ourselves away and move along. I'm running out of magnet jokes. After all, this isn't really my field. I'm glad we got away before things got kinetic between them. Speak of the devil, here he is. Kinetic is the energy related to moving objects, the energy of motion. There are many forms: vibrational, rotational, and translational. You look rather worn out and hot. How about we move along? Speaking of hot, this scorching little guy is thermal. Other than being swiped right, thermal is the vibration of particles within an object. In hotter objects, the particles vibrate faster. Colder objects vibrate slower, but still have energy. The energy is stored in places like the human body, ovens, and hot coffee. That let you back up, didn't it? Couldn't have been more perfectly timed. Here he is, light. Strangely enough, light is the only form of energy visible to the human eye. Why could we see the others? Well, that's just called a plot hole. Light travels in waves, and like his brother, kinetic, light is very fast. The fastest, actually. Oh dear. Now here is gravitational potential. Oh, hang on. Hang on. Gravitational is associated with objects at height, in relation to its mass. Can we get a medic? Now, where were we? Yes, chemical. Chemical energy comes from chemical bonds, atoms and molecules interacting.
Hey, when's it my turn?
Now, don't be so rude and wait your turn. Sorry about him. He's sound energy, and he can be quite loud and intrusive. All right. We'll have none of that. It's your turn now, then. When an object vibrates, the energy is transferred in the form of a wave, which moves through the air before reaching our ears. Usually, the energy involved in sound is far less than other forms of energy. All right. I've had enough of this nonsense. Let's get the last three out of the way. This is electrostatic. Sparky little fellow, isn't he? Ever been walking around in socks and touch something metal and get a nasty shock? Well, blame him. Electrostatic is generated with the movement of electrons. Shocking, isn't it? Now, how about you move along, little fellow? Time is money. Now, who's left? Yes, elastic potential. I thought it would be a stretch to think this was nearly finished. Now, this rubberhead stores energy when he is stretched, squashed, or twisted. So imagine a catapult or an inflated balloon. Give us a quick demonstration. That hurried that one up. Oh, you've got to be pulling my leg. I mean, this is nuclear. Now, don't mind him, he's just fission. Nuclear is generated with the nuclear interactions between splitting atoms. The only thing splitting now is my head, however. The fusion of hydrogen and helium in the sun is an example. Now, before you explode or scream or destroy anything, I'm gonna make like an atomic bomb and blow off. So that's the wonderful world of energy. What would we do without energy, huh? What would we do?